Chapter 2 is, in many ways, it's the most important chapter that we're going to cover this semester. There's a lot of topics in Chapter 2 that are going to come back again and again in the rest of the semester. And if you don't get these concepts in Chapter 2, then you're going to struggle in later chapters. Chemistry is an experimental science, meaning you're going to go into the lab and you're going to be recording measurements, you're going to be doing calculations with those measurements, and sometimes we're going to be dealing with numbers that are either very large or very small. So how to deal with those numbers and how to put them in your calculator and do calculations with it can be problematic. For example, we're going to learn about the size of atoms. Atoms are incredibly small. The diameter of an atom of boron is 0 point and then 10 zeros, and then 85 meters. So there's a couple of fundamental problems with dealing with a number that is this small. One of them is just keeping track of all of the digits. I'm not even sure if I put 10 zeros when I wrote that number down. It's very difficult to notice an error like that. It's also a problem to put a number like that in your calculator. Not only do you have to worry about the right number of zeros, but most calculators don't have this many places on the screen for you to enter a number like that. So the solution is to use what's called scientific notation. In scientific notation, we're going to take a number like this, which is normal notation, and we're going to move the decimal point. And when we move the decimal point, the key is you have to get a number that's between 1 and 10. So it has to be greater than 1 but less than 10. Another way to think of this is you need to have one non-zero digit and then the decimal point. You can see we have a 0 and then the decimal point, so this is not proper scientific notation. So if I do that with this diameter of the boron atom, I'm going to move this decimal over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 times to get the first digit being greater than 1 and less than 10, which is now an 8. So I'm going to write the result of this step. I have an 8 and then the decimal point and then 5. And then I'm going to write that times 10 raised to a power. And the power is however many places I had to move the decimal point. And that power, that exponent, is either going to be a positive number or a negative number. In this case, we had to move the decimal over to the right, so this is going to be a negative exponent. So you always get a negative exponent if you move the decimal point to the right, and if you had to move the decimal point to the left, you're always going to get a positive exponent. So in this case, we had to move over 11 times, so the power is 11, but it's to the right, so it's to the negative 11th power, and it still has the unit m, you're going to learn later on, stands for meters. So here are three numbers that are in normal notation. You notice in the 5,000 example there is no decimal point. And later on, whether a number has a decimal point or not is going to be an important concept for a different reason. But for now, if there were a decimal point, it would be right here. So to get a number, a non-zero digit followed by the decimal point, I have to move over 1, 2, 3 times. So I end up with 5 and then the decimal point, and then times 10. This is raised to the positive third power. So you don't have to write a positive exponent. You can if you want to. And notice I did not include these zeros for a reason. We're going to see that later on when we get into what's called significant figures. Whether or not you should include the zero when you write it down is something we're going to learn later. The next example, I have to move this decimal to the right, so I'm going to get a negative exponent of 1, 2, 3, 4 times, and I'm left with the first non-zero digit, 2.5704, which is a number between 1 and 10, and then times 10 to the negative fourth. If the exponent is negative, you must put the negative sign. It's unlike the positive sign. And then 63.21000, I only have to move the decimal over one place, so I get 6.321, and we're going to learn later on why I include these zeros and not the zeros in the 5,000, and this would be times 10 to the first power. Now, very important, what if you had a number like 4? How do you write that in scientific notation? Well, the decimal point would be right here, and it's already a number but greater than 1, less than 10. So I don't have to move this decimal point anywhere. So if I don't have to move it anywhere, I had to move the decimal 0 places, my exponent is a 0. So 4 in scientific notation is 4 times 10 to the 0 power. If you remember from math class, anything to the 0 power is 1, so 4 times 1 is still 4. In all of these examples, we're not changing the value of the number, just the way that we write it down.